Hey guys, welcome to day 57 of Codeforces Everyday until GM. Hope y'all enjoyed the little collaboration episode yesterday. I think I might do a little more of them more often. I think it's a little more fun to add in an episode every once in a while where I do it with a friend, right? Because usually it's just me, and then sometimes you have like the dead silence where I'm thinking about a problem. I think solving the problems actually go faster with somebody to bounce ideas off of, which is helpful sometimes. Like obviously you want practice where you're solving problems on your own, so it's not going to be like a regular thing. But every once in a while, I'll invite a friend on to do problems with me, and yeah, they can help fill in some of the dead air when I can't think of anything. But yeah, let's jump straight into this problem. Replace with occurrences. So problem D for div 3. Okay, let's see. Given an array A, let f of x be the number of occurrences of x in the array A. For example, when A equals 1, 2, 3, 1, 4, f of 1 equals 2. So f of x is the number of occurrences in x in A. So 1 occurs twice, 3 occurs one time. Okay, that makes sense. You have an array B size n. Please determine if there is an array A of size n such that f of A equals f of ai equals bi for all I between 1 and n. If there is one, construct it. Otherwise, print -1. So our input equals t equals int input. And then for in range t, we take an n equals int input. And then b equals map a list map int input dot split. Okay. For each test, okay. So we have an array B size in. Determine if there's an array A size in such that AI equals BI. For the first case, it can be shown that no array matches the requirement. For the second case, AI equals BI. So 1, 4, 5, 6, pure 1, 2, 3. Times respectively, thus the output array is correct as. Okay, so f of ai is equal to bi. So f of 4 is equal to 1, f of 5. So this could also be 1, 2, 2, 3, 3, 3. And then this last case is. Okay. So, given our array, f of what equals bi. So, why does first case fail? 1, 2, 3, 4. if a was equal to 1, 2, 3, 4, f of 1 equals 1, okay, f of 2 equals 1. Because, okay, so we would need 2 2s, and then 3 3s, and then 4 4s. That wouldn't work. Right. So, now the last case, uh, we need f of a to be equal to 6 in every case. So a can be anything, but we need 6 a's. So for each number, for each f of a, one, two, two, three, three, three. We're gonna have 1. Vi is 2. 2, 2, 3, 3, 3. So f of 1 is 1, f of 2 is 2. F of 3 is 3. F of AI wait, so is BI. So f of 1 would be 1. F of 2 is 2. F of 3 is 3. Huh. Okay. So we can't sort the array or anything. So what about this case? 1, 2, 3, 1, 4. How would we go about constructing this? We need f of a is equal to 1. And f, so f of ai, let's do a1, a2, 2, f of a3 equals 3, f of a4 equals 1, and f of a5 is equal to 4. But yeah. So this would be impossible because n is 5. We need to create an array length 5. The sum of this is already 1, 2, 3, 4, 5, 6, 7. Hmm. 1, 2, 3, 4, 5. Okay, this is 6. we call f of 1, f2, f2, f3, f3, wait. So if any of these are the same, they can overlap. Since these are the same, they can overlap. Alright, so then we only count this as 2. We only count this is 3, 4, 5, 6. Since these overlap, we can count 1. And then, but these don't overlap, so they have to all be different. So this is impossible. Okay, so I think we can check impossibility by using a set and the length of the set. So it's like set set b equals, okay, so if len set v is less than or is greater than, wait, if sum, it's not length of set b, it's sum of set b is greater than n, print -1, continue, right? Because if we check these other cases that work, it's 1. Set b is 1. Wait, set b is just 6. So sum is 6. 6 is not greater than 6. So we don't hit this. Else, can we do like 4? Can we set b? Okay, this is kind of complicated. These are all sorted. Like, what if I want a case where it's not sorted and works, you know what I mean? Like f of 1 equals 1 and like f3 equals 1. What can I do with this? Like we have a 1, 3, b equals 1, 3, a equals 1, 1. What can I do with this? Like, f of b, there's 1, 1, there's 1, 3, they add up to 2, and it's equals 2. I have I can't have another 1. I can't have another 3. Or if I did have another 1, f of a equals b. Right, so, okay, never mind. This is a. This is b. I would need another f of 1. Wait, this isn't right. F of 1 equals 1. F3 equals 1. If I have another 1, these are 2. Why did I construct A first? Why didn't I construct B first? Construct B first. Let B to have 1. Then f of what equals 1 and f of what equals 1 can be any number, right? So just like 1, 2, which means our A would be like 1, 2. Now if I had a 2 over here, means f of what equals 2. Since f of 1 equals 1 and f of 2 equals 2, then we can't use those anymore. We have to do 3. We'd have to do 3, 3. So this is impossible unless I do like this. So what if I have like when b is 1, 2, 1. Start off with 1 again. 2. Okay, that means we need multiple 2's. Do like 2, 2. Then 3. Okay. Because f of 2 and f. Wait. So f of 2 is equal to 2. Yes, f3 is equal to 1. So I think what we have to do is from b we have to we can't use a set. Like if b had 3 2's, like 2, 2, 2, then it would be impossible. N would be 5. So this isn't right. Sum of set b is 1 and 2, it's 3. But it's still impossible because we can't have So the count. F of A equals B. We can, no way can we make 3. Wait. F of two. So f of this thing needs to equal 2. So we have to use 4 and have 2 4s. So the count mod. Okay, first of all, the f function is just a a dot count. So f of x is equal to a dot count x, right? But the thing is, we don't have a, we have b. So we're basically saying a dot count x needs to equal we're going to replace x with I. A dot count I needs to equal b of I. So given a b, our process will be, like, for example, we have this 1 2 1 2 2 2 2. Our process will be, we start with 1s, 1 1. We can never use 1 again. To fulfill 2, we need the next number. Okay, we check. We start with 1, we check if it's fulfilled, we can never use 1 again. We check the next one, f of 2 equals 1. We just place it here, it's not fulfilled. Check if the next is a different number. If it is, we use 3. Fulfill it. It's fulfilled, so we can never use 3 ever again. Now 2. Try every unfulfilled first. Since this is unfulfilled, 2, we check this, it's fulfilled. We check this one, it's fulfilled. We can never use 2 again. Now for this, we have to use 4. It's unfulfilled. Move to the next. Try all the unfulfilled first. And now it's fulfilled. So I think I need a stack. Or I need an array of unfulfilled. Let's just call it unfulfilled since I have nothing better to call it. unfulfilled for I in range, or for we need a counter equals 1. For num in B, and then we can have an A array 2. A dot append counter if oh wait, we have to A dot append counter if A dot counter A dot count counter equals num does not equal num unfulfilled dot append counter counter plus equals 1, and then wait, so what's going on here? We are checking the first number, it's 1. We append it to A, 1. If it is, our counter becomes 2, and we append nothing to unfulfilled. We check the next number, 2, append 2. So our unfulfilled is 2. Our counter becomes 3. Our next number is 1. We append 3. It works. So our next number is 2. And our counter is 4. So before we append counter, we need to try for num for in unfulfilled if we need to see if we can put unfulfilled there. So what we do is for in and unfulfilled, if a dot counter if a dot count in plus 1 equals num, a dot append in unfulfilled dot pop dot remove in break. Flag equals false. Flag equals true. If flag, and we do all this stuff. This doesn't work though. It's like is less than or equal to num. Is less than num. In elif is equal to num. So this isn't going to be right, but there should be a good proof of concept, or at least we can probably start debugging from here. We need a way to check -1 still, and we just need to see what's happening with this. So we have no appends. That's not right. Oh, if not flag. One, two, two, two. That's supposed to fail this case, but it seems to work for these two cases. Now, we need a way to check -1. So, what's it doing? It's going in the first time. It doesn't go through any of this. It goes here. Append 1. And then this doesn't happen. So now our counter is 2. Goes through again, nothing in unfulfilled. So here append 2. And unfulfilled is 2. And then it's 3. Go through this. We want a different number. or go through here, but now we have an unfulfilled. Wait. But unfulfilled needs to check if it's a scene number. Right. If it's not, we can move on with another number. So do we need another array? Um, so the number of occurrences of hmm, f of a equals b. Currently what we're doing is we're kind of just simulating, but it's too slow, first of all. And second of all, I'm missing like two parts of it. Like, there's gotta be a better way to do this. F of a is equal to b. What's the trick for this problem? Mm, okay, so this is what I'm thinking right now. Okay, but I don't know if it works for this. Okay, what was that one case? 1, 2, 2, 3, 3, 3. We have like group these. Right? And then we had to check if let me think. It's like counts. A dot counts. So like count, like if I have a count array, position 0, count 0 is 1, count 1 is 2. But then this is just B. But, okay, but what if it's like this case over here? 1, 2, 1, 2, 2, 2. Count 0 is 1. Count 2 or 1. 2. Count. And then I need to do what would we do with this? if we were to group these, we'd group these like this, and then like this, right? So we have a counter, the count of 1 equals 2, and the count of 2 is equal to 4. Now check if it's possible. We would mod by 1 and by 2. If it's equal to 0, then it's good. If it's equal to anything else, then it's impossible. Right? So what we can do is okay, so here's something. These need to be different numbers, right? It's we have like a different number for it's count 2 divided by it's count I divided by I is the number of different groups. This is the check possible. If this ever does not equal to 0, print -1, call it a day. And then we need to split it into groups. Starting from 1, we can have a groups array. It'd be, so we have 2 divided by 1 is 2. So we get 2 groups, len 1. And then we get 4 divided by 2 is 2. We get 2 groups, len 2. Right? And then count 3 is 0, mod 2 is 0. So we get 0 groups, len 3. How do we know when to start? Or when to end? guess when we get to the end of count, like this would be I, right? For I in range. Len count. And then we just populate like wait, but we also need to store the order of these. Ah, fuck, this doesn't work. I guess we have to traverse through B. Actually, okay, yeah, we have this. We don't need the, it's two, it's two arrays, length of 1, two arrays, length of 2, and then 4 in B in range. Yeah, for in B, we do we think for okay, it's this. This is I I equals 1, I equals 2. If in, okay, so we do n will equal to one of these, right? So this we can name groups. So we do group n. Okay, so we can do 2 print plus equals indexes. It's 1. So okay, no. So we need to somehow. Okay, I feel like I'm close. It's like some combination of these operations. So we need to. Okay, step 1. Step 1. Let's move over here. Count. I guess we can, when we're counting, we can store the indices. Right? So like count 1 equals, we can define a count array, and count, oh, so count indices. Count and store indices. So count I equals blah blah blah. So example would be count, if we take this case, count 1 is equal to 0, 2. In step 2, check possible. So for I in range, then we can just do for I in count. For count, for, yeah, okay, for I in count, if len I mod I is not equal to 0, return -1, and then step 3, we need to form groups. To do this, it's for I in count len I divided by I, and then 2 int. This is the length of each group. Right. Wait. 0, 2. Groups. Then I divide by I. Okay, but then we lose the order we want it to be in, right? Because we stored the indices for a reason. How do we keep the indices without... Okay, wait, so this case we would have count I, count 1 equals 0, 2, count 2 equals 1, 3, 4, 5. Now we break this into 0, 2. Break this into 1, 3, 4, 5. Now we define A equals times in for num in A for I in range A for I in range in A I if I counter equals 1 if counter in we gotta check what group he's in. Bro, okay. Alright, let's just code in what we know so far. Right. So let's get some code down. First things first. Step 1. Count. For range in plus 1. Right. Is it for 1 to n plus 1? I think it matters too much. It's like this, and then for I in range in count B I dot append I. is going on? Okay, so count should be I'm gonna make count a dictionary. For I in range in, count bi dot append I print count. Count. Let me see if I remember. Count dot get bi by default empty array dot append I. Okay. What's going on with this? Like this. Okay, we should use this instead of get. Right. Yeah, so 1 shows up at index 0, 2 shows up at index 1, 3 shows up at index 2, 4. Okay, yeah. And then in case this 1, 0, 2, 3. Okay, yes. This is exactly what I want. This is step 1. Step 2. Check for impossibility. For I in count dot, okay, for value in count dot values, if len value fuck, okay, for key in count dot keys, if len count mod key does not go to 0, print -1, continue. Right, so keys here would be 1, 1 mod 1 is 0, so pass. 1 mod 2 is not 0, so print -1. Alright, so we should pass the first case, but why are we passing these two cases? Print key count key when count key. Print -1 3 times. Break. Flag. Goes false. Just set flag. Goes true. If flag print -1 continue. There we go. So now should just get one -1. Yes. Now for step 3. This is the hard part. For each okay, so A equals times in, right? So we should have -2 1 3 5 1 3 4 5 and then so we start with 1 2 3 4 5, 6. Counter equals 1. For values in count dot values, print limit equals len values. Oh, I need key value pairs. Can I do index? I don't know. Let's count dot keys for key in count dot keys. Limit equals len count key divided by key. While and then we need to go through what's the best way to do this? I don't want to use another loop. I think I'm gonna have to. It's like for index in, okay, so just for I in range, for I in count key, AI equals counter. Temp plus equals 1. Well, I just do limit minus equals 1 if limit equals 0. I should use a temporary variable. Should be faster. Temp equals 0. Temp plus equals 1. if temp equals limit temp equals 0 counter plus equals 1. Print A. Star. So 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6 is not correct. Zero. Okay, so AI equals counter. I should do this change anything? No. Okay, so let me think. What's going on here? Alright, let's only look at this case for now. Zero, zero, 1, 2, 3, 4. 0, 0, 1, 2, 3, 4, 5. Yes. So I and 0. I counter 0, 2, 1. Counters 2. Temp equals limit here. Temp is 0. Temp plus equals 1. Okay, wait, this makes sense. Counters 2. And we should print A as well, I think. Okay, 2 counter. Oh, there's something wrong with this calculation, I bet. Because it's 2. Wait. 2 divided by... The key is 1, 2, 3. Here's my math on this. Count. The length is 2 divided by wait. Yeah, how does this work out for 1, 2, 2, 3, 3, 3? It's 0, 1, 2, 3, 4, 5. Should be twos. Then it's like 2, 3. Counter is 1, 2 groups. 1 divided by 1, 2 divided by 2 is 1 group. 3 divided by 3 is also 1 group. 1 divided by 2 divided by 1 is 2 groups. So the length of these groups should be length divided by key. And this is a group count. So our limit should be the group count divided by our group count. What is the length of the group the length of the group divided by the key is the group count. To get our group count, the length of the group divided by the key is a group count. To get the limit, we take the length of the group divided by the group count, which is 2. Wait, was something is not right. For length of the group divided by, to calculate group count, it's the length of the group length of the group divided by key. The length of the group divided by key. group count. To get so our limit is just key? Yeah, our limit is just key. Wait, what the fuck am I doing? To key, yes. Yes. Okay. 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 I think this works. Jeez, this question killed me. Question is it fast enough? TLE. I wonder if I can do this. I don't know if this makes any significant difference. I want to see what this prints. Yeah, okay. Anything else I can do for this code? I mean, it's technically O to the end because it's like they iterate over like in, right? Print state. Oh wait, yeah, it would fail. Everything else seems to be in order still. I don't know if this made it any faster, but we might have to get rid of the arrays. The arrays might have, or the dictionaries might have some overhead. I pull out the C++. What else can I do to make this faster? Change this to desktop. Plus this color one for I range 1 and plus 1. All this should stay the same, I think. Okay, I think this is slightly faster because dictionary lookup is supposed to be harder than just index. I don't know. I'd still get stuck. Nothing like major changed. It was accepted, so fuck me, I guess. But we'll take it. Dude, this question was terrible. I need to bookmark it and review it. Codeforces is being slow. If y'all enjoyed this video, be sure to like and subscribe. I will see y'all guys tomorrow. Bye. Oh, there it goes. Bookmarked. Bye.